using types effectively. So, what does that mean is the first question. So, if you look back at the recent evolution of C++, from one point of view, it's largely about increasing our capability for dealing with types. And that means things like massive expansion rate, 11, things like decal type, auto, we've got null coming up. So, one of the things that you hear a lot at conferences lately is like how C++ is getting things from functional languages. So I wanted to reassure you that this talk isn't about any of these things, which you might think about when you think about functional languages. And in particular, probably M word. But functional languages like ML and Haskell do have lots of things they can teach us about types. In particular, using them expressively and effectively, and the key thing is making illegal states unrepresentable and making illegal behavior be a type error. And so that was kind of the evolution of this talk. C++ is definitely moving in this direction, in my opinion. And so, well, the first question is, what is a type? So when I'm asked this question, I get lots of different answers. Some potential answers might be, one of the original motivations for putting types in C that Dennis Ritchie had was that the new hardware was supporting floating point, and so his compiler needed a way to figure the difference between integers and floating points and what opcodes were output. A lot of people, because we're C++ programmers and because we're concerned with performance and because we come from the background of C, we tend to think about types as in a very representational manner, like the way the data is stored in the memory. Another way we can think about it is sort of the object-oriented view of types, so characterizing what operations are possible and perhaps what are not possible, or determining the values that we can assign to something, or in some way determining semantic meaning of data. Now, just know about the representational viewpoint. One of my friends tweeted and gave me grids for this talk and said, or Facebook, and said, only Lua would have one equal true evaluating false at type on my day back in April. So of course I replied, how can one be equal to true in my best functional programmer hat? One is an integer, two is a boolean, they can't be equal. Lua is correct here, and it's your view of the world as false. That's the smiley face you said, my friend. So in this talk, I want to take a little look about how just a little bit of type theory can help us think about better APIs and more closely modeling our data. And so I want you to think about a type as being a set of values that can inhabit a given expression. And to that end, it might be finite, like a boolean, or infinite, like a vector. But in some sense, a type is characterized by the cardinality of the set, the number of things that can fit into that bucket. And types in this sense are static, they are things that expressions have and therefore things that programs have. So this is I want to show this talk, this tutorial, because you're going to do some work here. So let's play a little game, help you thinking about types. So I'll tell you a type, and you're going to tell me how many values it has. So how many things can fit in that bucket. And there are no tricks here. If it seems obvious, because it is, shout it out, I'll try and listen. So let's set the value to level 1 of the game. How many values is it? 2, right? 2, obvious. Right, good. Level 1, sufficiently easy. How about now? 256, yes. A very smart crowd, of course, you are, very cheap people. Let's get a little harder. How many values now? I heard 0, I heard 1. I'm still hearing 0 and 1, so there's some confusion, there's some disagreement. So there's a proposal for me to get a regular type, it's true. You certainly can't instantiate a value of void, but you can return it from a function. Here's another way of making a type that has 0 inhabitants. And here's this rather curious construction, let's see another way. Yeah, there's some confusion because you can return it from a function, but you can't instantiate a value of type void. So, maybe basic has it right. Basic has function versus procedure thing. This was my intended to start with basic. Basic is correct. Alright, so some conclusion output. So I'm going to say 0 for this one. How many values now? 1. Yes, I heard 1. 1. Any value of this type you can make is indistinguishable from any other value. So, it's 1. How about now? 3. Oh, 256, someone said. A representational thinker in you. The answer is 3. So if you were to make it true, this is in the memory, this is the byte, right? So if you were to make a value, you could cast it to a binomial thinker, and it could be effectively at that point you would have broken the semantic link between the type and the representation. So I'm saying that's not a member of this type. The type has 3 members. And this situation is somewhat similar to what we think of as an unconstructed object. So after the memory has been reserved, but the constructor hasn't yet run, the representation is, what you're going to do. The memory is there, but you haven't yet turned it into an object. You haven't yet turned it into a member of the type. Okay, so 3. And now, how many values are there of food? What can we say? Yes, I heard cardinal empty. So we can say about this type foo that it has as many values as T has, whatever that might be. Whatever we instantiate it with, it's going to have as many values. Alright, so that was level 1. And already we're seeing, so if we think about types of being the number of things we can put in the bucket, then we can say that these 2 types are equivalent. And I hope we can all agree on this point. You can do anything with a bool that you can do with a negative. So, let's move on to